So let's take a look at cylinders and quadric surfaces. So looking at cylinders first, they can have a couple different types of equations, but some of the general equations are going to be x squared plus y squared equals 1, and y squared plus z squared equals 1. So notice that in a three-dimensional coordinate system, we have three variables, obviously x, y, and z. But cylinders' equations only have two of the three variables, which tells us that whenever you see only two variables, you know that it's going to be a cylinder. So obviously that 1 just tells us the radius of the circle, so like the basis of the cylinder. So if we take x squared plus y squared equals 1, this top equation for example, notice the z variable is missing. So whatever the variable that is missing, that is going to be the axis of the cylinder. So if I try to draw a cylinder on this 3D coordinate plane here, this is going to be the cylinder with the equation x squared plus y squared equals 1. Since the z variable is missing, so that means the axis of the cylinder is going to be on the z-axis. And also the radius of the circle is going to be 1. Now if we were to draw in this case y squared plus z squared equals 1, notice the x variable is missing, so the axis of the cylinder is going to be on the x-axis. So it's going to look something like this. The radius of the circle is still going to be 1, but it's going to be on the x-axis. So now the difference between quadric surfaces and cylinders is that unlike cylinders which have only two variables, either xy or zy or zx, quadric surfaces are going to include all three variables. Now there are going to be 6 of these quadric surfaces that we'll be taking a look at. So the first surface is going to be an ellipsoid, so just think of a sphere but more in the shape of an ellipse. So it will look something like this. And so the standard equation of an ellipsoid centered at the origin, 0, 0, 0, is going to be x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. Now the special thing is if a and b and c are all equal, then the ellipsoid is classified as a sphere. And so the next quadric surface is going to be the elliptic paraboloid. So it's going to look something like this, where we have in the shape of a parabola and in 3 dimensions. Now the equation for this is going to be z over c equals x squared over a squared plus y squared over b squared. Now keep in mind that it doesn't always have to be in the form z over c. Sometimes it could also be x over a or y over b. Now whatever is raised to the first power, so in this case z is the one raised to the first power, that is going to be the axis of the elliptic paraboloid, as shown in the graph. And so the next surface is going to be a hyperbolic paraboloid. And so it might look something like this. Now I apologize for my drawing. If you want to search it up on Google, you can as well to get a better idea of what it looks like. And so the equation of this hyperbolic paraboloid is going to be z over c equals x squared over a squared minus y squared over b squared. So it's basically the elliptic paraboloid, but with the minus sign. Now the next type of surfaces are going to be the cones, and so they can look like this, where they're going to be both on the positive, or they can be on the positive z-axis and on the negative z-axis. And so the equation for a cone is going to be z squared over c squared equals x squared over a squared plus y squared over b squared. So now notice there's going to be, or all variables are going to be taken to the second degree, or to the second power. So now for a hyperboloid of one sheet, it's going to look something like this, with sort of like an hourglass shape. And so the equation of this is going to be x squared over a squared plus y squared over b squared minus z squared over c squared is going to equal 1. So it's similar to the equation of an ellipsoid, but with a negative in between the y and the z. So now for an hyperboloid of 2 sheets, they're just going to be separated. So in this case, it's going to be one on the positive z-axis and one on the negative z-axis. So for a hyperboloid of 2 sheets, this is just going to be separated. So in this case, there's going to be one on the z-axis, positive z-axis, and then there's going to be one on the negative z-axis. And so the equation is going to be negative x squared over a squared minus y squared over b squared plus z squared over c squared is going to equal 1. Now, once again, I apologize for my bad drawings, but if you really want to get a good idea of what these surfaces look like, then just feel free to go ahead on Google and search these up. So let's say we have to reduce the equations to one of the quadric surface equations and then identify the surface. So for number 1, we have z squared equals 4x squared plus 9y squared plus 36. So how could we get this to look like one of the quadric surface equations? Well, the first thing I would do is factor out a 36. So I'll start by going z squared equals 36. Now if we factor out a 36, the first term is going to be 4 over 36 x squared, and the next term plus 9 over 36 x y squared, and then plus 1. Now the next thing I'll do is simplify the expression and go ahead and divide over the 36 to the left side. So we'll get then z squared over 36 equals, now 4 over 36 is 1 over 9, so we get x squared over 9, and then plus 9 over 36 is going to be 1 over 4, so we get y squared over 4, and then plus 1. So now what I can do is get all the variables to one side and then leave that 1 or that positive 1 on the right side. So I'll go ahead and subtract over the x squared and the y squared, so we get negative x squared over 9 minus y squared over 4 plus z squared over 36 is going to equal 1. So now it is in the form of negative x squared over a squared minus y squared over b squared plus z squared over c squared equals 1. So that tells us that this is the equation of an hyperboloid of two sheets. So now for number 2, we have x equals 2y squared plus 3z squared. So notice that one of the variables, x, is only raised to the first power. So I'm going to go ahead and start by rewriting the right side of the equation. So we have x equals, instead of 2y squared, I'll rewrite it as y squared over 1/2, and then plus z squared over 1/3. Now what can I multiply both 1/2 and 1/3 by so I can get a whole number in the denominator? Well, if I think about it, if I multiply 6 times 1/2 I get 3, and then 6 times 1/3 I get 2. So let's say I multiply both sides of the equation by 1/6. So then I'll get x over 6 equals, I get y squared over 6 times 1/2, obviously 3, and then plus z squared over 6 times 1/3, which gives us 2. Now this is in the form of z over c equals x squared over a squared plus y squared over b squared. But instead of z raised to the first power, in this case we have x raised to the first power. Now this equation is going to be the equation of an elliptic paraboloid. And so this one equation is going to be the same. It is also going to be an elliptic paraboloid, but instead of its axis being the z-axis, this time x is raised to the first power, so its axis is going to be the x-axis. So now for number 3, we have 4x squared plus y squared plus 4z squared minus 4y minus 24z plus 36 equals 0. So the very first thing I'm going to do is go ahead and group like variables, or similar variables. So I have the 4x squared, I'll just keep that there. There is no other x, so I'll just keep it on the very left. Then we have plus y squared, and I'm going to group that with minus 4y. And then we have plus 4z squared minus 24z. Now 36 is just a constant. I'll go ahead and subtract that over to the left or to the right side of the equation. So I'll get that it equals negative 36. Now whenever you see the different variables, such as y, one is raised to the second and one is raised to the first, whenever you see something like that, it's probably a good indicator that you have to complete the square. So let's go ahead and focus just on the y variable right now. So if we have y squared minus 4y, now obviously this is going to, our a term is just 1, our b term is going to be that negative 4, and then we have to have that c term. Now how do we find that c term? Well, we take the b term, so negative 4, divided by 2, and then square it. So basically we get negative 2 squared which gives us 4. So that is going to be that c term. Now, remember, if we add 4 on the left side, so if we have 4x squared plus y squared minus 4y, now we added 4 for our c term, we're also going to have to add 4 over to the other side as well. Now notice this is going to be a perfect square trinomial, so we can reduce that into y minus 2 squared. So now let's focus on the z variables. Now we have 4z squared minus 24z. So the first thing I'm going to do is actually go ahead and factor out that 4. So we have z squared, or we have 4 times z squared minus 6z. Now we have an a term here, which is just 1. Our b term is going to be negative 6, and we need that c term. So when we divide our b term by 2, we get negative 3, and then we go ahead and square that. So our c term is going to equal 9. So we can go ahead and add 4 times z squared minus 6z, and then we go ahead and add 9 here. Now this time we added 9 to the left side, but we're technically adding 4 times 9 since we factor out that 4. So we're going to add 36 on the right side. Notice this is going to be another perfect square trinomial. So it's going to end up being actually 4 times z minus 3 squared. So 4 times z minus 3 squared. And then that's going to equal, well, the negative 36 and the positive will cancel, so we're left with 4. So now if I go ahead and divide both sides of the equation by 4, we're going to be left with x squared plus y minus 2 squared over 4 plus z minus 3 squared equals 1. And so this is going to be in the form of x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. And so this equation is going to be the equation of an ellipse. And since we have right here y minus 2 and z minus 3, the center of this ellipse is not going to be at the origin, but it's going to be at the coordinates 0, 2, 3.